Now, like I said, latitude and longitude is a type of grid. If you've ever seen a globe, then you know that the different lines that go one direction versus another direction, latitude and longitude, you can pinpoint exactly where you are. And they actually do it in degrees, minutes, and seconds. So if you, as you get into higher math, we actually will do some conversion with degrees, minutes, and seconds. Degrees kind of tell you one measurement, and then you can think of minutes and seconds as just smaller ones. So if you have an inch and a quarter of an inch or an eighth of an inch, you're just getting to a more precise measurement. That's what you're doing with latitude and longitude. So when you see those latitude and longitude numbers, you will be able to see a little more specific, especially when you're looking, like for, let's say, example, hurricane season. They'll show you exactly where it is, latitude and longitude. It'll have decimals or it'll have minutes and seconds, and it'll show you exactly where it is because it's more precise than just the grid. If you look at this particular one, you can see that clearly there are things in between the graph lines. And so getting more specific in your measurements helps you get to a more specific place. All right. For this particular one, it tells us where we are. And so they've given us letters down here at the bottom, and they've given us numbers on the side. And so when you think about math, you usually think of X, Y's, right? And all numbers, which is what you typically do when you graph. But for a map, any type of legend is going to help you. And by legend, it's like a description of what's going on with the map, is going to help you. And so this is actually going to give you your position here, and this is going to give you your position here. And so they give you an index. Bloomington, if you look here, Bloomington is in this group, C. And it is up here near the 5. So the closest measurement that we have is in this 5 block and in this C block. So they don't actually represent the lines, they actually represent the blocks. And so there's a large area that you can find in this particular block. Cairo, if we look at Cairo, we're going to C and up to 1, and so we're right here. B2, so we're going to go to this block in here, and you'll find that Carbondale is here. And so this is how we would read a particular grid like this. We would say, okay, we can look at the different pieces and we can figure out where the different pieces are based on this particular coordinate plane. And this is just one type. This is a map with an index of the map. All right. Any questions on reading something like this? All right. So given those, I want you to find either the city or the location of those. All right, the first definition we're going to look at is what's called an ordered pair. Hopefully this is review for you. An ordered pair is a pair of numbers x, y, typically is the variables that we use for them, describing a point in the Cartesian coordinate plane. The Cartesian coordinate plane is this guy right here, what you're used to seeing. The Cartesian coordinate plane, that's what this is called, named after the mathematician that it is given credit for. We have some axis and origin. X-axis, this is your horizontal axis. That is your x-axis there. It runs horizontally. You have your y-axis, which runs vertically. And then you have the origin, which is the point 0, 0. It is in the center of where those two meet. You do have your quadrants in your coordinate plane. It goes counterclockwise, starting in the top right. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. The x-coordinate is the first coordinate in your ordered pair. It does tell you your movement left and right, left and right. So your x moves you left and right on the Cartesian plane. And then your y is your second coordinate. It moves you up and down. So it's going to be the second one in your coordinate or ordered pair. And it's going to tell you how you're going to move up and down. So you're going to have positive x, positive y right here. So that's going to be both positive in this quadrant. You have negative x and positive y in the second quadrant, negative x, negative y in the third, and then positive x, negative y in the fourth. All right, and so as you move around the Cartesian plane, you will move according to how those x's and y's tell you to move. All right, so the first thing we're going to do is graphing, and hopefully, like I said, this should all be review. Move x units left or right. From that position, move y units up or down, graph the point, and label it. All right, so you want to make sure that you have a label for your points. You can't just plot them. You need to actually put a capital letter is how you typically label your points. And so we're just going to use the letters that they've given us here. The first one is 2, 1. So we're going to move x and y, 2 x's up 1 y. And we're going to put our first point here at 2, positive 1. And we're just going to label it with an A. The next one moves us left 3, up 4. We're going to label that with a B. 0, that means we don't move it all left and right. If your first coordinate is a 0, then you're going to be on your y-axis. So we just move down. And that will be where our third point would be. All right. If they don't give you letters, you can also label it with the actual point. So let's say we didn't have these A, B's, or C's. You'll notice that they labeled theirs with the actual coordinates. And so they labeled them like this. And so if you're not given letters, you can either assign a letter or you can label it with the actual coordinates themselves. All right, questions on putting points on the coordinate plane? All right, let's try. The most common mistake is people flip their X's and Y's, or they put their up and down movement first and their left and right movement second. And so given the actual points, then you need to recognize then how you're moving. And so if I look at this first one and I need to figure out what the coordinates are, I'm going to say, how did I move? Well, to get here, I would have had to go left 1 and down 2. Those are both negative movements. Left 1, that's my X. Down 2, that is my y. And so you're literally just walking around the graph here. Down 2, left 1, down 2. Look at the next one, E. Again, I would have moved left 3 units, and then I would have moved up 5 units. And if it's not labeled, just count it. So when I'm looking at this one, I can count that I've gone 1, 2, 3 left, and 1, 2, 3, 4, 5 up. And so I'm going to do my X first, my Y second. For the last one, F, I moved right, so that's a positive movement of 4. And I did not move up or down, so you do need to put your 0 there. You cannot leave it out. Your points are always consist of an X and a Y. All right, so go ahead and label these. So you should have had a positive X and a negative Y there. F was on the y-axis, so you didn't move left or right, you just moved up 3. So scatter plots are exactly what they sound like. You can notice that they're not in a specific linear form, so it's not like they actually form a line. It looks like the points are literally scattered all over the coordinate plane, which is why it's called a scatter plot. Typically what they do is they have a group of information and they are putting it down. Now you'll notice something else about this is that it doesn't necessarily start at 0, all right? And you don't necessarily have the same units. By that I mean is if you'll notice down here we are moving by 1 unit, but here we are moving by 10. And so when you do a scatter plot, or even if you do a word problem, you may want to adjust your particular coordinate plane to fit what you need it to fit based on the word problem you've been given. So for example, the handout is all 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on yours, right? And so when you do a scatter plot like this, you're not going to want to use 1 through 10. First of all, your numbers don't even start, but higher than that. So you're going to have to adjust your chart to fit the problem that you've been given. And so with scatter plots and with word problems in general, you're going to find this to be true. You'll also notice that they only showed the first quadrant. Well, in this particular case, we're talking about height and weight. It's a height and weight comparison. And so when you're talking about height and weight, you're not going to have a negative height or a negative weight. And so that's going to eliminate the second, third, and fourth quadrant. All right. And so they just showed the first because there's no need to even use the other three quadrants. They're not applicable to height and weight. All right. And so often in your word problems, if you were to do one, you're only going to need the first quadrant because you're talking about something physical and you're not talking about something that goes in the negative. But if you were having something that compared temperatures, then you might have a negative because temperatures can go in the negative, right? Or sea level could go in the negative. And so there are times when word problems will have it and there were times when they won't. So you have to use your logic here as to whether or not you need your other ones or whether they would ever go. When you're doing a scatter plot, you are literally just placing them where they go. So you'll notice they took the 64 and the 130, 64, 130, 60 and 124. And so they set this up based on their lowest, right? So their lowest was 58. And so you'll see they started at 58. And their highest was 64. And so it went to 64. And on their chart, they went one above it. So they went one over. They didn't necessarily have to do that, but they did. And they did the same thing with their weights. You'll notice that their lowest weight was just below 100, and they chose to start down here. You could have started at 90 if you wanted to when you were setting this up. Their highest weight was 160, and so you'll notice they went one above it, just to make it logical for them to be able to put it out there. Often what we do with scatter plots is when we get into linear equations, which we're going to get into the next chapter, then they will, or in the next section rather, they will draw a line to see if there is a correlation. Sometimes scatter plots show a distinct relationship happening. And this one actually does too. We actually have this little outlier here. We have this 64 inch and 130, and that's actually a little bit of an outlier based on the people that they measured. All right, this one seems to be not fitting with the rest. But the rest of them, if I were to take this particular one and I were to draw a line to represent it, you can see that even though they don't fall exactly on it, they fall back and forth across what looks like a linear equation. And so it seems as though based on this, that there is what's called a positive correlation between height and weight. Well, that makes sense, all right? And so if I have a little toddler who's tiny, you can expect that they would weigh less than maybe a 15-year-old who's up here, clearly, right? They have more height, they probably have more body weight as well. And so there's a correlation, and you can see there's a positive correlation between those two. That's not always true from scatter plots. And this is sometimes what they will do to see if there's a correlation. Medical places will do this. They'll say, okay, we have people who took this medication and we have this side effect. Is there a correlation between those two? And they will plot it out and see, is there a correlation between this and that? Are there other factors that maybe are affecting it? All right. They'll look at age. Is there a correlation between age and this? And they will see. It's not always going to fall directly on the line because we're talking about people, right? And so clearly it's not like if you are 6 feet tall, then you must weigh this amount. That's not how this is going to work. But you should see some type of correlation happening between them. I also use the term outlier here, and that's a term that you're going to see when you start doing maybe probability and statistics. You'll see most of them fall something on that line, and then you'll see one that kind of is off the norm, okay? And again, we're talking about real life stats. We're not talking about what we think is going to happen, all right? And so these are real life height and weight comparisons. And so then you should see a little bit, but you'll still see a correlation, all right? And so when you do a scatter plot, you're typically looking to see, is there something going on between two factors? Are they related? Sometimes it'll be positive correlation. Positive means it's going up. Sometimes it'll be a negative correlation, means it's going down. Or sometimes you will not see any correlation and you'll do a scatter plot and they will literally be all over the graph. And there's no way you could draw a line to fit that particular one. And then there's no correlation. And that tells them something else. Hey, there is no correlation between headaches and this medicine. They actually have nothing to do with each other. That actually helps us eliminate maybe a factor that we're trying to see when we're doing these.